how many values of x between minus 19 and 98 satisfy cos squared of x plus 2 sine squared of x equals 1? Now, when I was attempting the problem for the first time, I actually got this wrong because I assumed it meant in degrees, but it means in radians. You know that because there's no degree sign above here, right? So you know it's in radians. Oh, never mind. All right, so you know we're working in radians. Just to point that out, I guess. And we want all values of x within this range here that satisfy cos squared x plus 2 sine squared x equals 1. Now, if you know your Pythagorean identities, then you know that, I guess the most basic one is sine squared x plus cos squared x equals 1. Now, if you see here, this looks very similar to this, right? They look extremely similar, in fact. So we can break this down into cos squared x plus sine squared x plus sine squared x again equals 1. Okay, now we know that sine squared plus cos squared equals 1. And actually, wait, let's we can actually prove that. If we take a right triangle if we actually let's first take the unit circle, so circle of radius 1, that's 1, and then we construct a right angle triangle on this unit circle such that this side here, the length here is never mind. So if we construct a triangle on this unit circle, so circle of radius 1, with this length here is 1, then if we look at this, then we can see that, well, if we call this angle here x, then we can say cos of x equals, well, adjacent over hypotenuse. This is the adjacent, this is the hypotenuse. So adjacent we'll just call a divided by 1. So we now know that a equals cos of x, right? Because we just multiply both sides by 1, and that's that. Now we can do the same thing for the other side, and we can say that sine of x equals opposite over hypotenuse. The opposite is just, let's call it O over hypotenuse, which is 1. So multiply both sides by 1, we get sine x equals the opposite. So we know that for any angle x, as long as our hypotenuse is length 1, which we know it is because it's a unit circle, and the unit circle has a radius 1, we know that the adjacent side, which is going to be this side here, is cos x. We know that the opposite side to angle x is going to be sine x. Now, if we use Pythagoras' theorem, we get that, well, since a squared plus b squared equals c squared, in this case, this is a, this is b, this is c, we know that cos squared x plus sine squared x equals 1 squared, which is just 1, right? So there's no need to include the square. That's how we get it. So yeah, just to, put that in there. So we know that sine squared plus cos squared equals 1 from what I've just shown. And in here we have a cos squared plus sine squared, which is the same thing. So we can substitute 1 in for that. So we can say that's 1 plus sine squared x equals 1. Therefore, sine squared x equals 0. Now, this is the part where it gets slightly more complicated. So sine squared is the same as sine x times sine x. And we need that to be equal to 0, which means that, or alternatively, instead of saying that, well, actually, no, let's continue with this for a sec. So we know that sine of x times sine of x must equal 0, which means that these two, they must, since they're the same, they must both be equal to 0. So we can just simplify that and say sine x equals 0. Alternatively, you could have just taken the square root of both sides here, and you would have got sine x equals 0. And yeah. So essentially we're looking for all the values of x for which sine of x is equal to 0, but specifically within this range, right? This range of minus 19 to 98 exclusive. And exclusive just means that you don't include the endpoints, which in this case are minus 19 and 98, so you don't include them in the range. So if we look at let's look at the sine graph. So if we draw this, we're going to get something like that. Okay, so since we're working in radians here, we'll label this graph in radians. So this is sine x, and this is x. So if you know your trigonometric graphs, then you know that sine of x hits 0 every pi radians, right? So this is pi radian, or this is 0 radians, then it goes to pi radians, and this is 2 pi radians, or 360 degrees. This is 3 pi, and it goes on and on and on. So essentially, we're just looking for all of those values which are lower than 98 and greater than negative 19. So let's start with the negative 9. Oh, sorry. Let's start with the negative 19 first. So if we start with the negative 19, let's say, well, how I did this was I just tested out a bunch of values, right? So I know that pi is roughly equal to 3. Sorry, give me a second. I'm gonna go get some water. All right, so we know that pi is roughly equals to 3. I'm just approximating that, and if we get like a bit too close for my liking, then I'll put the 0.14, but we can just approximate it for now. Say pi is 3. Now we want pi times x for, well, I guess x is just a number, right? So we want x times pi to be to be greater than negative 19. And if pi is roughly equal to 3, then we want 3x to be greater than negative 19. And we can see that x equals 6 is x equals negative 6 is the lowest value of x that satisfies this. Now, we're, technically you could go lower and you could say 6 point whatever, right? But here we're only after integers, right? Because we know that x pi, or I should say sine of x pi, always equals 0 for any integer x. We say x in the elements of integers, right? So only after integers, and x equals 6 is the lowest integer that we can get that satisfies this. So yeah, I guess it's kind of close. It gets a negative 18 roughly. So I guess we could say estimate it further and say 3.1 times 6, but that's just going to be equal to 18.6, which is still, I guess, negative 18.6, which is still greater than negative 19. So we know that there are, well, it goes from negative 6 works, negative 5 works, negative 4 works, and that goes all the way to 0. And then after that, we have from 0 to, whatever's the greatest value of x, such that sine of pi x equals 0, right? So if we go down, where was I? Here. So we want pi x to be less than 98. Now, I'm going to do the same thing I did last time and say pi is roughly equal to 3. So you can say that 3x has got to be less than 98. Is 98 a multiple of 3? No. Is 97 a multiple of 3? No. Is 96 a multiple of 3? Yes. So let's start with trying 96. So 96 is a multiple of 3. Divide that into 3, we get that it's 32. So we know that x equals 32. but we don't actually, well, okay, so let's try this out. So if we have x equals 32, then we have 32 pi is less than 98. Since I approximated, I just want to make double sure, so I'll be more accurate and say that pi is roughly equal to 3.14. So I have 3.14 times 32 has to be less than 98. Now, if I say that 3.14 is 314 times 1 over 100, and that's being multiplied by 32, which is less than 98, or well, we'll see. Then I can just multiply these two and divide it by 100 to see whether this inequality holds. So let's just multiply 314 and 32 really quickly. 314, 32. That's 8260214 and you get 84001. So that's pretty big. So we have that, we get this thing here, right? And is that correct? 10,000. 30 times 30 is 900, so times 300 would be about 9,000. That looks about right. So we know that we have this times this, which is 10,048, and that's being divided by 100, right? And that's, well, for the inequality to hold, it has to be less than 98. But if we divide this by 100, then that's going to be 100.48, which is not less than 98. So if we go back, well, we know that pi is roughly equal to 3.14, right? And we've said that 32 pi, we've tried 32 pi, right? But 32 pi is too big. But if you see here, if we just, if we take 31 pi, then we're going to have this minus the pi, which is about 3.1, which is going to take us down to 37 point something, which is less than 98, so that works. So that means 31 is our last good value. So we know that it goes from -6 all the way to 0 for the negatives, and it goes from 0 all the way to 31. Now here is the last step. So we know which values work, and now we just need to count these values. So they go up in ones, which is pretty nice. And now if we want to count the number of things in a list, as long as we do the same thing to each value, then everything's good, right? So here I could just add 6 to every value. So I can just say add 6 to everything, add 6, and then we get, well, minus 6 plus 6 is 0, and then minus 5 plus 6 is 1, 2, 3, goes on all the way to 31 plus 6, which is 37. Now, 37 plus 1, well, from 0 to 1, there are 2. From 0 to 2, there are 3, as in like 3 numbers. From 0 to 3, there are 4. From 0 to 5, there are 6. And that works the same with, well, if we say 0 to 37, that's 38, right? So there are 38 values that work. Yeah, I guess that's the final answer. I mean, I'm probably gonna check to see, because I mean, that 31 pi it probably gets quite close. So let's try 314 times 31. We get 4130214 94379 97.34. That works. So and it's like a decent amount of dust. Oh wait, if we do 97 or 9734 or 9734 divided by 100, we get that is equal to 97.34, which is a decent amount away from 98, which is the upper limit, right? So we can safely assume that works and say that there are 38 values that satisfy this this equation over here. So yeah, that's it.